So good morning, everyone. Welcome to this session. My name is Quanjie Lin, and this is my teammate, Oliver Liu. So we are both from Google Istio security team. So today we are going to talk about how Istio leverage Envoy SDS, the secret discovery service, to fortify the Istio security features. So first, I will have a brief introduction about what is Istio and Istio security features we offered, especially on the authentication flow. Then Oliver will take over to talk about in Istio 1.1 how we leverage the Envoy the secret discovery service on the Istio gateway certificate management. So during this talk, if you have any questions or feedback, feel free to ask. So first, let's have a talk briefly about Istio. So I guess probably some of you have heard or even used Istio before. If not, you definitely have heard like service mesh or the microservice pattern. So in recent years, the microservice pattern becomes more and more popular. The advantage is very obvious. We can have smaller teams using the program language that they feel comfortable with and focus on their business logic. Also, we can have faster development and faster deployment. However, this pattern also brings many new problems that we need to solve. For example, if I have an environment like have hundreds of services running, how can I do the service discovery? Another use case is if I have a new feature I want to roll out, I want to route like certain percentage of user traffic to do some A/B testing and how to solve the problem. So this is the first problem that Istio will solve for you. That is the traffic management. The second problem we need to solve is with so many services running in the cluster, it would be great if we can offer the operator a central place to monitoring the service running status. If the availability job in a certain service, we could give the operator some tools to dig into the logs and find the problem. So this is the second problem Istio is going to solve for you, the monitoring and the telemetry. The third part is what we will focus today is about security. Think about in a network that you don't have any security feature enabled, which means each service can talk to the other service if a VM or the port got compromised. It can steal the sensitive user data. It will be a disaster. That's why we will focus about the Istio today, Istio security feature today. So next, let's take a look at the Istio, the overview architecture. As you can see from this picture, we have two parts. The upper part is the Istio data plane. Basically, in each user service, we have the Istio sidecar running by side of it. So this part is transparent to our application developer because Istio sidecar injector will automatically inject the Envoy sidecar for you. So the Envoy sidecar, after it gets its configuration from the Istio control plane, it can do many functions like it can do the routing, or when it routes the traffic to upstream cluster, it can do the outlier detector or the error handling. Also, it can do the mutual TS, the TLS termination for you. So this part is about the data plane. As you can see from the lower part, we have three major components in Istio in its control plane. The first is pilot. So basically, pilot has a service registry. It keeps information about all the services, service instance, and endpoint, all those informations in real time in its memory so that it knows about the service mesh topology at real time. Also, pilot is able to accept the policies. For example, the security policies, and combine the service registry and the policy. Pilot was able to generate and push the sidecar configuration to each of the sidecar running inside the mesh. So Envoy already provide the Discover service like the LDS, CDS, RDS, listener, cluster, routing, endpoint, the Discover service. So Pilot will follow the API interface and push the Envoy configuration to the sidecar. And SDS is is another API interface that Envoy recently bring that we will talk about detail later. And Mixer, you can think it as a telemetry component. So basically, it's an attribute process engine. All the sidecar in the mesh will send a matrix, for example, the source service name, destination service IP address to the Mixer. Mixer will process those attributes and send it to different telemetry backend, like the Stackdriver, so that our operator have a central place to monitoring the service running status. The last thing is the CA. So we have Citadel run as the CA in Istio 1.1. Basically, the CA is responsible to sign the certificate, and all the components will trust the CA in the mesh, so that after they get the signed certificate, they can use the certificate to authenticate each other. So we will cover this in more detail later. Next, let's take a look at the Istio security features that we offer. As you can see, there are so many terminologies in this picture, but from a developer's personal view, there are two major problems we want to solve. First is how to secure the service-to-service connection. The second problem we want to solve is the end user, how to secure the end user request. So for the first problem, service-to-service authentication, we first need to have the identity for the service. That's why we have the identity provision workflow. So we basically provision the private key certificate for each service running inside the mesh. So after the service has the identity, we have the authentication policy so that we can enforce, say, I can have the mutual TS enforced at the mesh level or at the namespace level or even at the service level. If I'm in a migration status, I can configure my authentication policy accept both the encrypted traffic and the plaintext traffic. That is permissive mode. Another thing is access control. So let's take a step further. After we do the authentication, I want to specify some authorization policy. For example, we can write an authentication policy to specify that we allow service A have read-only access to service B, or service B can have the read-write permission to service C. That is what authorization policy do. So this is about service-to-service communication. Another part is the end-user request. So there are two scenarios. One is the end user can access the service inside the mesh, for example, the operator. Another use case is we can have some external user that try to access from outside the mesh. And for this case, we can have the authentication policy enabled on the Istio ingress gateway. So whenever an end user request come in, we can do the authentication for this end user at the ingress level. If this is a malicious user, the connection will be rejected. Otherwise, the request will be forwarded inside the mesh. So this is two categories of problem we try to solve using the Istio security features. Next, let's talk briefly about the authentication flow. So we talked about the certificate many times in previous slides. So what exactly is a certificate? As you can see, I put here a decoded format of the certificate. Basically, it has two things we want to notice here. First is a timestamp. So each certificate has a lifetime. It has an issued timestamp, and it has an expire timestamp. So basically, when certificate expires, we need to rotate the certificate. That's the problem that the Envoy SDS will try to solve for you. Oliver will cover that later. Another field in the certificate is the subject alternative name. Basically, this is the identity of the service. As you can see, it's in the SPIFFE ID, the service running in the default namespace and running as the default service account. So this certificate is signed by our CA. So all the components in the mesh will trust the CA. so that after the service have the certificate, they can use it to authenticate each other. Also, the certificate can be used to encrypt the traffic so that the traffic between service to service are not plain text anymore. So this is the sidecar. So we also can have the certificate that on the Istio ingress gateway, so that whenever end user, the end request come in, we can authenticate the backend service, use the certificate on the Istio ingress gateway. So next, Oliver is going to talk about how we manage the certificate used by the ingress gateway in Istio 1.1 and in our recent release. Okay, thank you.
Hello, everyone. So this is Oliver from Google. So I'm going to talk about a little bit about the SDS and things before SDS, and also show a demo for using Cert Manager plus the Let's Encrypt service to provision certificates. So what's the old days? The legacy cert management with secret volume mount is what we used in 1.0 and 1.1 by default. And in this flow, we are relying on the Citadel and the secret volume mount for delivering their internal certificates to their workloads. So basically, for the internal certificates, we have a Citadel that which is their which is their service accounts created in their cluster. And for each service account, it will generate a secret and key pair and put that into secret. And the API server will automatically do a secret volume mount to every of their workloads, so that the workloads will be able to access the key answers through the local files. And for the external certs, the admin or the cert manager or any progress that you have can write to the API server the secrets and put their key and external key and their certs into the secret. And in the same way, the gateway can mount them and use it through the local files. The drawbacks of this approach includes one, performance, which is the Envoy hot restart is required whenever you rotate the key and certs. And two, security concerns. So first thing is their keys are transferred through the cluster network, even though this is secured by TLS, but it's still something that we want to avoid. The second security concern is key and cert stored as the files on their pod. So if you have like a malicious process, that process might be able to access the file. So what is SDS? SDS is Secret Discovery Service introduced in Envoy. It's an API to manage the X509 certificates and keys for Envoy, so that the key and certificates can be dynamically delivered to Envoy. And the key and certificate rotations will happen on the fly without restarting Envoy. So the flow will be looking like the following chart. The Envoy will load the certificate and key through SDS from the SDS server. And in turn, the SDS server will talk to some upstream certificate issuer. In this case, it might be Citadel, it might be API server, or it might be any custom CAs. And the protocol that you define here can be customized. So let's talk about especially how the SDS helps us to manage external certificates for the ingress gateways. So this covers a lot of use cases for our customers. They want to say deploy ingress gateway with many of their certificates, external certificates, because they are running a couple of different services in the backend, and it might be a multi-tenant scenario. So in that case, they want to be able to like dynamically put more certs on the ingress gateway and rotate them or remove them at the same time. So how to do that? The admin or whatever cert manager or process that the admin runs can put their external key and cert into their Kubernetes secret. That's the first step. And then once the secret is there, the ingress gateway will get their configuration from pilot. And in that configuration, the pilot will tell it, okay, get the SDS configuration, get the SDS key and cert from this local web address. So that this local web address is actually the ingress gateway agent, which is running as a container in the same pod the ingress gateway is running. So the gateway knows how to talk to the agent. It will send an SDS request asking for the key and cert. And then the agent will retrieve the key and cert from the secret on the API server. So the API server will check if it has the permission. If yes, they will return the secret to the agent. Otherwise, it will return an error. The agent, in turn, will respond their SDS request by sending either the key and cert or an error to their gateway. Once the gateway gets the external certificate, the external callers are able to call this endpoint through TLS. To recap, the advantages brought by SDS includes enhancing the security. The private key never leaves the node because the private key are generated by their agent instead of on some remote service. The private key is not stored in local file system because it's always in memory. It's not through the local files, the volume mount. There's no interruption to the traffic because the cert rotation will not require Envoy to restart. And the last thing is it decouples the certificate management flow from the underlying infra. Remember, in the legacy system, we are relying on the Kubernetes secret volume mount, which relies on Kubernetes feature. And now, since we have SDS, whatever service that you expose as the SDS server can be used here. And also, this agent allows you to customize APIs between the agent and your upload certificate issuer as well. So it makes it very, very flexible for you to deliver the certificate and generate the certificate. So how to integrate with Cert Manager and Let's Encrypt? I guess a lot of people are interested in this topic. This graph shows you the overall workflow. As I described earlier, the gateway talks to the gateway agent through the SDS. That's the first part. And the agent will talk to the Cert Manager, right? This time it's not API server. The Cert Manager is a pod that is running on the cluster. And what it does is it takes a couple of configurations and it will be able to provision the certificates for, say, DNS domain. And then it will be able to send this to the Let's Encrypt service. It's a bunch of challenges, a description, according to their Acme protocol. And then the Let's Encrypt service will basically verify if you are owning that DNS. If yes, it will send back the certificate generated and signed by a public PKI. And then the Cert Manager will be able to deliver that secret to their gateway agent. The gateway agent, in turn, returns that to the gateway through the SDS. To offer more practical reference, I have created a demo. It's recorded. So, sorry. Yeah. So this demo shows provisioning less encrypt certificates for ingress gateway through the SDS and the Cert manager. All right, let's start it. Starting from the very, very beginning, we first set up the GCP cluster project, right? And then we download the binary. Currently, it's 1.1.7 as default. And then we add some Helm repo. This is all the typical process that you have to do when you are using Istio. And this stage, I'm deploying the ingress gateways with the SDS, and as well as the Cert manager. Take some time. By the way, I clipped a couple of slide time there because I want to reduce the time of the demo. All right, so it's deployed. Let's see. The ingress gate, so the Cert manager here. The ingress gateway has 2 containers, even though it's waiting for the other container to start up, but you can see it has 2, which means one of them is in the Envoy, the other one is the agent. And I'm looking at the external IP for the ingress gateway, have that IP. I will record it. That's the external IP. I want to make that external IP permanent, so I do this. Create the address, and then it will be preserved for me. I won't lose it. All right. So now I have the external IP. And I will create the demo namespace to deploy a demo app that I will interact with. Basically, this demo app just shows me the headers it receives. It's very simple. All right, have the demo namespace and get the pod. It's HTTP. Now I will deploy the gateway. The gateway now has 80 and 443, 2 pods. One for unsecured, the other one for secured. And for the secure one, it refers a secret to use. For the virtual service, it will check their host, and also for that host, it will redirect to the internal service, which is the HTTP. I will apply the virtual service as well. Now the gateway is configured right. The 443 port will not work because the certificate is still empty. Now, what I'm doing is I will register a DNS domain. Here I'm using oliverliu.org, which I provisioned through GoDaddy. And I have configured that to use their name service servers of their GCP. So you have to go, if you do that, you have to go to whatever your provider and configure the name servers to be point to the name servers set here. Added a record, which is pointing to this IP. This is called demo.oliverliu.org. All right. And then I added another one, which is a CNAME, to redirect all the subdomains under demo.oliverliu.org to demo.oliverliu.org. This is not actually required in this demo, but I just anyway did it. So remember this name servers, you have to add that to your provider, DNS provider. And then I wait a few minutes, and then I checked the DNS is propagated to most of the DNS servers. And then I check, okay, for the HTTP, I'm able to actually get to this endpoint. That's cool. So the HTTP part works. And then what I will do is I will create a service account for the Cert manager, and the Cert manager will have that JSON file for the service account. It will use that to talk to the Let's Encrypt. Let's Encrypt will have that service account, and it will use that service account to manipulate the DNS server here under Google. So be able to verify that you own the DNS server. You own the DNS name. So I create a DNS admin here role so that the Let's Encrypt will be able to use that service account to access the DNS configuration. I download the key. All right, that's the service account. The key is the major part. So what I will do is I will copy that key here. It's a JSON. The first one is the key. The second one was created like before. I will rename that as clouddns.key.json. All right. So I have the key. Now I'm going to configure the Cert manager. I add that key into the secret of the cluster so that the Cert manager is able to access it. See, the key is here. And it has a special metadata which is indicating the project ID. Okay, here's the, let me pause a little bit here. Here's the configuration for the Cert manager. Its spec is, has Acme protocol specified, and that's the Let's Encrypt server address. And then this email is their account in their Let's Encrypt service. I use the private key secret ref here using the DNS01 standard in Let's Encrypt. Basically, it has the provider, which is a Cloud DNS, and then refer to the secret, which is what I put here, a clouddns.key.json in the Cloud DNS secret, right? The project is called KubeCon 19 -demo. All right. Apply it. And I create a secret. So the secret is basically like this. Let me pause a little bit here. Secret name is Let's Encrypt -demo. That's the secret that's going to load for the 443 part on the ingress gateway. The usual reference is Let's Encrypt -DNS. It's not very useful here. Common name in the certificate I specified here. DNS names I specified them here. Those are to be appeared in the certificate. And then Acme domains, it will verify those domains for the certificate. All right. Let me see how much time. Okay, I have 2 minutes. So after I deploy the secret, the Cert manager will start to work. It will try to create the secret and then talk to the Let's Encrypt to provision the certificates. See, I was checking the secret status. It created the order for resource, that one. It also creates a secret. what it does is it generates a key locally, and then the cert is still empty because it's waiting for the cert manager to deliver that cert for itself. Okay, then I'm checking the log of the cert manager. It takes some time, a few minutes to do that. And if you check the GCP, you will see the TXT type record here, which is sent by the Let's Encrypt for the challenge. Okay, now we have the certificate provisioned, and I can see from the log here, found status change for certificate demo cert condition ready false to true. So this means I have the certificate. Let's check the secret again. The TLS cert is written. The CA cert is not important here because it's only used for mutual TLS. Currently, in this demo, we are only using TLS. So let's change this to HTTPS to verify if it works. Okay, it works. See that log, and then we check the certificate. The common name is star.demo.oliverliu.org, and it's just created. By the way, I created this on Monday, so the timestamp is on Monday. Subject alternative name, DNS type, correct, demo.oliverliu.org. All right, that's it for the demo. I guess that's it. We have about 3 minutes left. Any questions? Sorry.
Of the agent?
Yes.
For pushing the SDS versus what the rest of Istio does, it pulls it from pilot or has pilot push it. So what was the choice of having an agent there versus?
Oh, right. The pilot pushes. Okay. So the pilot pushes their ADS and XDS, all the information for basically not related to the secret part. But it will have a reference there for the address and the name of the secret that you want to get. And for that cluster definition, you want to talk to that, for example, you want to talk to that address to get this secret. And that secret is used for retrieving the key and cert and its interaction. And then once the envoy gets that information, it will, okay, look at that, access that endpoint, that address, and then send the SDS request to it and retrieve that certificate so that this works in a whole, like, yeah. Other questions? All right. Thanks, everyone.